At first, the sun does not disappear. It simply begins returning lower each day. Its path across the sky becomes a little shallower. Noon loses some of its height. Shadows stretch farther across the snow. The hours of daylight contract, almost imperceptibly at first, until the change becomes difficult to ignore. At high latitude, this is more than the ordinary shortening of winter days. Earth is tilted about 23.5 degrees relative to the plane of its orbit, and as one hemisphere leans away from the sun, there are places where the daily solar arc eventually fails to reach the horizon at all. Then comes the final sunset. Not the last sunset forever, of course, only the last one for a while. Beyond the polar circles, there are periods when the sun remains below the horizon for an entire rotation of Earth. Travel farther toward either pole, and that interval grows longer. At the North Pole itself, the sun remains below the horizon for roughly half the year, while stations at lower polar latitudes experience shorter stretches according to their exact position. The result is called polar night. The phrase makes it sound simple, as though someone has switched off a lamp. But the real sky is more complicated. Even when the sun itself cannot be seen, it may remain close enough beneath the horizon to illuminate the upper atmosphere. Around the beginning and end of the season, a muted band of twilight can appear for part of the day. Deeper into winter, that indirect brightness weakens. Near the highest latitudes, there can be long periods when no true sunrise interrupts the cycle at all. This is the environment surrounding the research station tonight. From inside, the building seems almost detached from the landscape. There are illuminated corridors, computer screens, laboratory benches, warm kitchens, clocks, calendars, scheduled meetings, and all the familiar machinery of an ordinary working day. Outside, the sky has stopped participating. A window can show stars at an hour labeled 11 in the morning. Another glance after lunch may reveal almost the same sky. The distinction between morning and evening is no longer written in sunlight across the walls, and yet the station continues. Measurements still have to be made. Instruments still need calibration. Weather observations continue through the season. Equipment has to be maintained. Meals arrive at recognizable hours. People work, read, exercise, speak with families far away, and eventually try to sleep. The strange part is not that darkness surrounds all of this. The strange part is how quickly darkness becomes ordinary. Human beings have carried an astronomical clock above them for their entire history. The turning Earth creates morning and evening without requiring anyone to think about it. Sunlight reaches the eyes, changes across the day, and helps organize rhythms deep inside the body. When that strong environmental signal weakens during polar winter, studies of people living at high latitudes have found shifts in sleep timing and circadian organization, although the effects vary considerably between individuals and environments. So a wintering station must accomplish something unusual. It must become a clock, not merely a place containing clocks, but an inhabited system of light, meals, work, exercise, social contact, and repeated routines strong enough to give shape to days that the sky no longer defines. That transformation does not happen all at once. For now, there is only the station, surrounded by snow, cold air, and a sun traveling somewhere beneath the horizon. Inside, someone has just begun what the clock calls morning. Morning begins with electricity, before anyone steps into the corridor, before breakfast is served, before the first instruments are checked. The station has already begun changing the light. Fixtures that were dim during the scheduled night grow brighter. In some rooms, the change is gradual, more like dawn than a switch being thrown. In others, researchers deliberately spend part of the morning near bright lamps designed to provide a stronger signal than ordinary indoor lighting can offer. The goal is not to imitate sunlight perfectly. That would be impossible. The goal is to give the body a reliable message It is morning now. Behind the eyes, a small region of the brain called the suprachiasmatic nucleus helps coordinate the body's daily timing. It receives information about environmental light through specialized cells in the retina. These cells contribute to vision only indirectly. Their more important role here is to measure brightness and help tell the brain whether the outside world is behaving like day or night. Under ordinary conditions, this system rarely attracts attention. Morning light arrives. Evening light fades. The internal clock is adjusted a little each day, kept close to the 24-hour rotation of Earth. During polar night, that strong natural signal becomes weaker or disappears for long stretches. The clock inside the body does not simply stop. It continues running. But without strong timing cues, the relationship between sleep, alertness, hormone release, body temperature, and the station schedule can become less stable. Some people feel sleepy earlier than expected. Others remain alert late into the scheduled evening. Sleep may become more fragmented. Mood and concentration can shift as well. There is no single polar night response shared by everyone. Individual biology matters. So does previous sleep history. So do work schedules, artificial light, exercise, social activity, and the latitude of the station itself. This variability is one reason routine becomes so valuable. At breakfast, the station begins reinforcing the same message the lights have already started sending. People eat at a fixed hour, coffee is poured, chairs scrape lightly across the floor. Someone reads a weather report. Someone else reviews the day's maintenance list. A conversation begins about an instrument that has been behaving strangely in the cold. Nothing about the meal needs to feel ceremonial. Its power comes from repetition. Breakfast happens now. Work begins after this. Lunch will come later. Dinner belongs to another part of the day. These are small human events, but repeated consistently, they become time signals of their own. The body can respond to more than light. Meals, exercise, social interaction, and regular activity all contribute to the larger pattern of a day. They are weaker cues than sunlight for the central circadian system, but together they help prevent the station from dissolving into a collection of private schedules. That possibility is more realistic than it first appears. Imagine 12 people living in one building with no sunrise to gather them into the same morning. One person begins sleeping later. Another wakes earlier. A third has an overnight task and shifts meals to match it. Someone else feels no particular reason to go to bed at all when the sky looks identical at every hour. Within enough time, the station could contain several different versions of Tuesday. That would make more than sleep difficult. Scientific work depends on coordination. Safety checks depend on knowing who is awake and available. Field teams need shared schedules. Meals, maintenance, communications, and emergency responsibilities all work better when the people inside the station remain synchronized with one another. So the artificial day is not merely a comfort, it is part of the station's operating structure. After breakfast, the lighting stays bright in working areas. Researchers move toward laboratories, control rooms, equipment bays, or whatever spaces belong to that particular station. Computer displays come alive. Sensors send back readings from outside. Data collected through the previous hours begin to accumulate into something that can be examined. For the next several hours, the station behaves almost as if it were located anywhere else. The clock advances, tasks begin and finish. Someone grows hungry around lunchtime. Someone notices the familiar dip in energy that can arrive during the afternoon. The strange sky remains beyond the windows, but the day inside has momentum now. And then, many hours later, the process begins moving in the opposite direction. Work areas become less bright. The station's social spaces may take on warmer, lower illumination. People finish the final demanding tasks of the day. Exercise sessions end, dinner is served, screens are still present, but researchers who are careful about sleep begin paying attention to how much bright light reaches their eyes during the hours before bed. The station is creating evening, again not perfectly. Artificial lighting does not reproduce every changing wavelength, intensity, and angle of natural daylight. A ceiling fixture cannot recreate the full experience of watching a winter sun approach the horizon. But the circadian system does not require poetry. It requires signals, brightness earlier, less brightness later, activity during one part of the cycle, rest during another, and repetition again and again until the schedule becomes predictable enough that the body can begin anticipating it. There is something almost mechanical about this, yet from inside the station it feels deeply human. A day is being assembled from pieces: light, food, work, conversation, movement, a closed bedroom door at night, the hands of a clock. Each piece carries only part of the message. Together they form something close enough to morning and evening that the people living here can organize themselves around it. And over time, a surprising shift can occur. The researcher who once looked through a window at 10 in the morning and felt unsettled by the stars may begin glancing at that same sky without much reaction at all. The clock says, morning. Breakfast has happened. The lights are bright. Everyone else is working. Morning, therefore, has become real enough. Outside, nothing has changed. Earth still turns beneath a sun that remains below the horizon. But inside the station, another kind of sunrise has been built. The darkness has another use. It is easy to think of polar night only as something the station must overcome. A problem for sleep, a challenge for the body, a condition that has to be managed with schedules and carefully timed light. But for science, the absence of the sun can also become part of the instrument. Across the polar regions, winter creates conditions that cannot simply be reproduced by returning in summer. The atmosphere changes, the snow changes, the upper air changes, the magnetic environment continues responding to the solar wind. Stars come available for longer observations. Weather systems move through landscapes with fewer interruptions from solar heating, and so the station does not merely endure the dark season, it watches it. Some measurements are valuable because they continue without interruption. A thermometer recording air temperature every day may seem almost modest beside a large telescope or a satellite dish, but a continuous record gains power from its consistency. Year after year, the same place is measured through the same seasonal cycle, including the months when reaching that place may be difficult or impossible for anyone who is not already there. At Germany's Noumea Station 3 in Antarctica, meteorological observations continue through the year. Weather balloons carrying radiosondes measure conditions above the surface, including temperature, humidity, pressure, and wind, while other instruments contribute to long-running observations of the atmosphere and ozone. The value is not only in any single launch, it is in the sequence. One balloon rises into the polar air, then another the next day, then another. The measurements begin forming a vertical history of the atmosphere, a record of how one layer changes against another. As winter deepens, a person standing outside during the launch may see very beyond the cone of a headlamp. The instrument sees something else entirely. It climbs through air that becomes thinner with altitude, radioing information back to the station as it rises. What looks from the ground like a single black sky is divided into layers of temperature, pressure, wind, chemistry, and motion. The darkness becomes organized by measurement. Elsewhere, instruments are listening to processes far above the weather. Earth is surrounded by a magnetic field extending far into space. Charged particles from the sun interact with that magnetic environment, and some of the most visible consequences appear in the aurora. The moving light can seem almost detached from the scientific station below it. In reality, it is part of a much larger system. Particles, magnetic fields, the upper atmosphere, and solar activity are connected across distances far larger than the station itself. Instruments at polar sites can monitor aspects of that interaction continuously, helping researchers study what is often called space weather. At Halley Research Station in Antarctica, observations include atmospheric science and space weather research. While long-running ozone measurements, they became part of one of the most important environmental records of the 20th century. Measurements begun in the 1950s eventually helped British Antarctic Survey scientists identify the severe seasonal depletion of stratospheric ozone over Antarctica reported in 1985. That discovery did not come from one dramatic night. It came from persistence, the same kind of instrument used again, the same part of the atmosphere examined again, numbers written down, checked, compared, and preserved until a pattern became too large to dismiss. This is one of the less visible qualities of research stations. They make patience physical. A station is a place where someone can keep watching after the weather becomes difficult, after the supply aircraft stop coming, after the sun disappears, and after the easy season has ended. Winter gives continuity, a human presence. Someone has to be there to maintain the instruments. Someone has to notice when frost gathers where it should not. Someone has to replace a component, verify a reading, restart a system, inspect a cable, or walk outside to understand why a sensor has gone silent. Automation can do a great deal, but at remote stations, a person remains part of the observing system. And there are other kinds of science for which the darkness itself is an advantage. At the geographic South Pole, the atmosphere is exceptionally cold and dry, and the long winter night creates valuable conditions for certain kinds of astronomical observation. The site has supported astronomy and astrophysics for decades, including instruments designed to study the cosmic microwave background and other faint signals from the universe. Because here, the absence of sunrise becomes something almost like observing time stretched across months. There is no ordinary alternation between daylight and darkness. A telescope can remain pointed into a night that does not end at dawn. The sky still moves because Earth is rotating, but at the pole, that motion takes on an unusual geometry. Stars appear to circle around the observer rather than rising in the familiar way seen from lower latitudes. The station beneath them continues its own schedule: breakfast, maintenance, data checks, sleep. Outside, the celestial sphere turns with a steadiness that has nothing to do with the clocks inside. This contrast is one of the defining experiences of polar research. Human time becomes carefully manufactured, while natural processes continue according to rhythms that may be measured in seconds, hours, seasons, solar cycles, or decades. A researcher may spend part of a morning adjusting an instrument designed to detect changes that are almost unimaginably small. Later, the same person might shove snow away from a doorway. The work moves constantly between scale. A sensor sensitive to the upper atmosphere, a frozen latch that refuses to close, a data series extending across 30 years, a glove that has to be dried before the next trip outside. Nothing about the daily routine needs to feel grand. That is part of what makes the station useful. Science is allowed to become ordinary there. Readings can be taken because taking readings is simply what happens at that hour. A weather balloon can be prepared because yesterday's balloon was prepared, and tomorrow's will be too. The station turns repetition into knowledge. By afternoon, someone may be sitting in front of several monitors, watching traces creep across a screen. One line records pressure, another shows wind, another may represent a signal from an instrument positioned well away from the living quarters, where contamination from heat, exhaust, or radio equipment has to be minimized. The researcher is not waiting for a revelation. Most days, nothing dramatic happens. That is useful too. A stable record matters because change can only be recognized against something that has been measured carefully when nothing unusual was occurring. Science needs uneventful days. It needs ordinary winters. It needs long runs of data in which the most interesting fact may be that a number stayed close to where it was expected. Then, somewhere inside that long continuity, the pattern may shift. A temperature changes, a concentration rises or falls, a magnetic disturbance arrives. A telescope accumulates enough observations for a weak signal to emerge from noise. The discovery, if there is one, comes later. For the person wintering at the station, there is usually only the next task. This changes the meaning of the darkness. It is no longer only the absence of morning, it is also an observational condition. A seasons in which the atmosphere, the ice, near-Earth space, and the distant universe can be watched in ways that become harder when sunlight returns. The long night is still difficult for the body. No scientific advantage removes that, but it gives the season another shape. The researchers are not merely waiting for the sun, they are using the time when it is gone. And somewhere outside the station, beyond the windows and the pools of artificial light, an instrument continues recording a world that never stopped moving, simply because human eyes could no longer see the day. There is another kind of instrument surrounding the researchers here. It has walls. From the outside, a polar station can look almost plain. A collection of angular buildings, raised platforms, service modules, antenna masts, storage areas, fuel systems, and narrow passages is designed around weather rather than beauty. Inside, every surface is part of a larger calculation. The first requirement is simple enough to describe: keep the cold outside. That becomes much less simple when the air beyond the walls can remain far below freezing for long periods, when strong winds strip heat from exposed surfaces, and when a damaged heating system can become a serious problem very quickly. A research station in this environment is not merely shelter. It is a controlled pocket of temperature, pressure, light, air, water, electricity, and human routine placed inside conditions that do not naturally provide any of them in convenient form. The walls are built to slow heat loss. Insulation is layered carefully. Windows are limited and heavily glazed. Entryways are often designed so that the outside air cannot rush directly into the inhabited spaces each time a door opens. You pass through one barrier, close it behind you, and only then open the next. Even this small movement has a purpose. Warm air is precious here, not because warmth itself is rare, but because every degree inside the building has been purchased with fuel, electrical power, machinery, maintenance, planning, and the work of people who must keep those systems functioning through the entire winter. You begin to notice this after living in the station for a while. At home, a radiator clicking on can disappear into the background. Here, heating has weight. A low mechanical hum becomes reassuring because it means the system is doing what it should. A ventilation fan becomes part of the sound of the building. Pipes are noticed, generators are respected. The station teaches you to hear infrastructure. Somewhere behind a wall, heat is being moved. Somewhere beneath a floor, a cable is carrying power. Somewhere in a service room, pumps, filters, batteries, controls, and backup systems are holding the interior environment inside a narrow range where people can work without thinking constantly about the weather outside. That is one of engineering's most successful tricks. When it works well, it disappears. A researcher sits at a desk reading data, while the building performs thousands of small acts of protection around them. The air remains breathable. The room remains warm. Water comes from a tap. Lights switch on. Computers run. A meal can be cooked. A person can take off the heavy outer layers required outdoors and walk through the corridor in ordinary indoor clothing. All of this can begin to feel normal. It is not normal, it is engineered. The distinction becomes clearer whenever someone prepares to step outside. The process begins well before the door opens. Clothing is assembled in layers. The purpose is not to create one thick barrier, but several cooperating ones. A base layer helps move moisture away from the skin. Insulating layers trap pockets of air that the body can warm. An outer shell limits wind and protects the insulation beneath it. Hands and feet require special attention because they lose function long before the rest of the body feels ready to stop working. A glove must allow enough movement to handle tools. A mitten may provide more warmth but less precision. Boots must insulate while also allowing someone to walk safely across snow, ice, metal stairs, or hard-packed surfaces. The face presents its own problem. Human skin was not designed for prolonged exposure to very low temperatures and strong wind, so only a small area may remain visible. A researcher who was recognizable indoors becomes, outside, a moving collection of fabric, insulated material, goggles, mask, hood, radio, and headlamp. The body becomes another carefully protected system. Before leaving, batteries are checked, radios are checked, tools are checked. The route is considered, weather matters, visibility matters, wind matters. How long the task should take matters. The station door is only a few meters away from the warm corridor, but once it closes behind you, those few meters begin to feel important. The first sensation outside is often not temperature, it is contrast. Indoors, the air had texture without demanding attention. Outside, the cold becomes immediate. It touches the narrow gaps around clothing. It settles onto eyelashes and fabric. Breath leaves the body as vapor and may collect as frost around a face covering. The snow underfoot produces a sharper sound at very low temperatures, each step distinct in the dark. Your headlamp reveals only a small portion of the landscape. A patch of ground, a cable, the side of a building, a marker pole. Perhaps another person walking a short distance ahead. Everything beyond that beam remains hidden. This changes the scale of the world. During daylight, even a flat polar landscape has depth. The horizon helps orient distance. Snow ridges and structures can be placed relative to one another, almost without thought. At night, the useful landscape shrinks to whatever the light can reach. A familiar route may feel different. A building a few hundred meters away can become nothing more than a cluster of lamps. The station behind you becomes one illuminated object surrounded by a much larger field of black. There is no need to make that darkness dramatic. It is simply a condition that changes how work is done. Movements become more deliberate. Partners stay in contact. Equipment is handled carefully. A task that might take 10 minutes in mild weather can take longer because gloves reduce dexterity and because every unnecessary movement costs warmth. Metal tools become uncomfortable to touch without protection. Plastic can behave differently in deep cold. Cables stiffen, lubricants thicken. Batteries lose useful capacity more quickly. Screens can become harder to read. Mechanical parts that worked easily indoors may resist once exposed. Polar fieldwork is full of these small negotiations between human intention and material behavior. A researcher may kneel beside an instrument enclosure and discover that the latch has frozen. That is not a scientific mystery, it is just ice. But the ice must still be removed without damaging the enclosure, while the wind presses against the outer layers and the fingers inside thick gloves become steadily less cooperative. A measurement may depend on something as ordinary as getting that latch open. This is where the polished image of science falls away. There are papers, equations, plots, and instruments sensitive enough to detect subtle changes in the atmosphere. There are also stubborn bolts, snow drifts, frozen connectors, doors that need clearing, filters that need replacing, a sensor that stopped reporting because frost accumulated in the wrong place. The science depends on both worlds. One world asks a large question about climate, magnetism, ice, or the universe. The other asks whether a person can keep a cable functioning through February for the people who winter here. The second question often arrives first. The work may continue for an hour, perhaps longer. The body keeps producing heat, but the balance has changed. The cold is always taking some away. Movement helps. Insulation helps. Food eaten earlier helps. But the limits remain real. The crew learns to recognize them. Numbness is information. Loss of dexterity is information. Shivering is information. A change in concentration can be information too. There is no reward for staying outside, beyond the point where judgment begins to degrade. The goal is not endurance for its own sake. The goal is to finish the work and return safely. Eventually, the instrument is checked. A reading is recorded. The enclosure closes. The tools go back into a bag, and the small group turns toward the station. From a distance, its illuminated windows seem brighter than they did before. Not because the lights have changed, because your eyes have. The building has become the warmest object in the landscape. Approaching it produces a very old kind of satisfaction. Shelter ahead, heat ahead, other people ahead. The outer door opens, cold air enters with you. Snow clings to boots and outer clothing. For a few moments, everyone remains inside the transition space, removing the layers that belong to the outside world. Hoods come down, gloves come off. Frost begins melting. Faces become visible again. The second door opens. Warmth arrives gradually against chilled skin. At first, it can almost hurt. Then sensation returns to the fingers. The smell of food may drift in from another room. Someone asks how the instrument looked. Someone else takes the radio. A wet outer layer is hung where it can dry before the next trip. The fieldwork is over, but the preparation for tomorrow has already begun. This cycle repeats across the winter. Warm building, cold field, warm building again. Each crossing makes the station's design more understandable. Insulation is no longer an abstract property of a wall. It is the reason your room remains comfortable. Backup power is no longer an item on an engineering diagram. It is the reason the lights stay on when the wind is moving across the ice outside. An airlock is not an architectural curiosity. It is a small chamber protecting the atmosphere people have created inside. The station teaches this lesson without ever explaining it directly. Comfort here is not the absence of harsh conditions. It is the successful management of them. And because the management is continuous, the people living inside gradually stop noticing how much work is being done on their behalf. They sleep beneath a roof, held warm against winter. They eat beside walls designed to conserve heat. They speak in rooms ventilated and powered through machinery maintained by members of the same small community. The environment outside remains severe. Nothing about the building changes that. The station does something more practical. It creates a boundary. On one side, cold air, snow, wind, ice, and months without sunrise on the other. A cup cooling beside a computer, socks drying near a vent, a book left open on a table, and someone walking down a lit corridor toward dinner. For most of the day, that boundary is so dependable that life can unfold almost normally. Then a researcher returns from the dark, closes the final door behind them, and remembers how much stands between a human body and the winter outside. By the middle of winter, the station begins to feel less like a workplace and more like a small world with edges. You notice this not because the rooms have changed, but because nearly everything that matters now happens inside the same few corridors. You wake here, you work here, you eat here, you exercise here. You speak with the same people here. You read, repair equipment, answer messages, wash clothes, prepare food. and eventually return to sleep without ever leaving the building, unless the day's work requires it. Outside, the landscape is enormous. Inside, life becomes compact. That contrast begins shaping the mind in ways that are difficult to measure with a thermometer or a weather balloon. Isolation at a polar station is not the same as being alone. In fact, privacy can become one of the rarest things in the building. A winter crew may be small enough that everyone quickly learns the rhythms of everyone else. You know who wakes first, who prefers silence at breakfast, who exercises after work, who leaves a mug beside the same computer every afternoon. Small habits become visible because there are so few competing details. At first, this can feel intimate. Later, it can feel crowded. And then, with enough time, the crew begins learning the delicate balance between those two sensations. Human beings need other people. They also need moments when nobody is asking anything of them. A polar winter offers both needs in concentrated form. The same colleague who may be the person you most want beside you during a difficult field task may also be the person whose footsteps in the corridor seem unusually loud. After several months together, a conversation that would pass unnoticed in ordinary life can linger. A small disagreement over food, equipment, cleaning, noise, or scheduling can acquire more weight than it deserves simply because there are fewer places for the mind to put that weight down. There is no drive home afterward, no walk through a different neighborhood, no casual evening somewhere among strangers. The people involved remain nearby. So good station life depends partly on learning how not to enlarge every irritation. This becomes a kind of social skill. A person learns when to speak, when to leave something alone, when to close a door for an hour, when to join the common room even if solitude feels easier, when to notice that someone else has been unusually absent from dinner. Nothing about this is dramatic. That is why it matters. Most of the strain in an isolated winter does not arrive as one obvious crisis. It accumulates in small forms. Sleep that was slightly worse than usual. A message from home that makes the distance feel larger. A week of bad weather. An instrument that keeps failing. A room that suddenly feels too small. A colleague whose habits have become impossible not to notice. A body that is still responding imperfectly to months of altered light. Each thing is manageable. Together, they can change the emotional temperature of a station. Crews prepare for this long before winter begins. Selection and training for isolated research environments often consider more than technical competence. A person may be excellent in a laboratory and still find long confinement difficult. Cooperation matters. Communication matters. The ability to tolerate boredom matters. So does flexibility. The winter does not care whether a problem falls neatly inside someone's job description. A scientist may help unload supplies. A mechanic may assist with an observation. Someone with no formal role in the kitchen may spend an evening preparing a meal because the person who normally does it needs rest. A small station works partly because rigid boundaries soften. People become useful to one another in several different ways. This has an unexpected effect. Relationships are built less through declarations than through repetition. Someone checks that your radio battery is charged before you go outside. Someone leaves a portion of dinner warm because your work ran late. Someone notices that you have been staring at the same problem for too long and quietly makes coffee. These gestures would be easy to miss in a larger world. Here, they form part of the station's infrastructure. There are mechanical systems that keep the building alive. There are human systems that keep the winter livable. Meals are one of them. A shared table does more work than it appears to. At a fixed hour, people who have spent the day scattered across different tasks return to the same room. The meal may be simple. Its importance is not. Eating together restores a rhythm that darkness and isolation can slowly weaken. There is a beginning. There is a middle. There is an end. Work pauses, faces are seen, voices are heard. For a little while, nobody has to interact through a radio or a task list. The conversation may concern science. It may concern weather. It may concern a film watched years ago, a badly remembered recipe, a city someone misses, or nothing important at all. That last kind of conversation can be particularly valuable. Not every moment at a polar station needs to carry the weight of the environment. Sometimes, people need to talk about ordinary things precisely because so little about the setting is ordinary. After dinner, the common room takes over another function. There may be cards, books, music, a film projected against a wall, a puzzle left unfinished on a table for several days. Someone may be writing. Someone else may be repairing a personal item with tools borrowed from the workshop. A few people may sit together without speaking much. The activities are modest, but they create separation between work and sleep. Without them, days narrow into a repeated sequence of task, meal, task, bed. And repetition, while useful for circadian stability, can become psychologically heavy when nothing else changes. So the crew creates landmarks. A birthday becomes more noticeable here. A holiday becomes something to prepare for rather than simply allow to arrive. The midpoint of winter can become an event of its own. Food may be saved for it. A room may be decorated. Someone invents a tradition that another crew will repeat years later without remembering who began it. This is one way human beings put texture back into time. When sunrise and sunset no longer divide one day from another, people begin making divisions themselves. A special meal, a weekly call home, a game on Thursday, a shared dessert after a difficult field day. These become small markers along an otherwise uniform season. There is another rhythm too, more private. At some point, most wintering researchers begin protecting a personal ritual, reading at the same hour, writing a few lines before bed, exercising alone, listening to music through headphones, working slowly through a book brought from home, looking through old photographs. The particular activity matters less than the fact that it belongs to one person. In a place where almost everything is shared, a private habit preserves a small region of identity. You are not only a member of the winter crew, you are still the person who arrived here carrying memories, preferences, unfinished thoughts, and a life extending far beyond these walls. That larger life can feel strangely distant. Messages travel quickly now, but emotional distance is not measured by transmission speed. A photograph from home may arrive in seconds and still seem to come from another season of existence. There may be daylight in it, trees, traffic, a crowded cafe, a family kitchen, people wearing clothes that would be useless outside this station. The ordinary world continues, while the winter crew lives inside a very different calendar. That knowledge can be comforting. It can also sharpen homesickness. Both responses are normal. So contact with home becomes another balance, enough to remain connected. Not so much that the life beyond the station becomes the only life that feels real. The people who adapt most steadily often seem to develop the ability to inhabit both worlds at once. They remember what waits elsewhere. They also remain present here. There is work worth doing here. There are people worth knowing here. There are nights when the common room feels warm enough that the distance to everywhere else recedes for a while. And sometimes, the station offers something no message from home can provide. A knock at the door, someone asking whether you want to come outside. No emergency, no broken instrument, just the sky. You dress quickly, the outer layers go on. A few members of the crew gather near the exit. The transition chamber opens, then closes behind you. The cold returns. The station lights remain at your back, and above the roof, something has changed. A faint green band has appeared among the stars. At first it looks almost motionless. Then one section brightens, the band curves. A second shape forms higher overhead, thinner than the first and begins to stretch across the sky. This is light produced high above. The station as charged particles, ultimately originating from the sun, interact with Earth's magnetic environment and upper atmosphere. The details can become complex very quickly. Particles are guided by magnetic fields. Atoms and molecules in the atmosphere are energized through collisions. As those atmospheric constituents return toward lower energy states, photons are emitted. Oxygen is responsible for much of the familiar green auroral light, while other colors can appear depending on altitude, atmospheric species, and the energy of the particles involved. You may understand all of this. You may have worked with data related to it, and still, standing beneath the moving light is different from reading the explanation. The crew grows quiet. No one has agreed to become silent. It simply happens. The aurora does not need commentary. Its movement is slow enough that there is time to notice individual changes. One arc fades, another gathers. A translucent curtain seems to fold along invisible lines written by Earth's magnetic field. The darkness that has complicated sleep for months now gives the light room to be seen. That contradiction belongs to polar winter, the same long absence of sunlight that can strain. The body also reveals a sky most people never live beneath for very long. The cold remains cold, isolation remains isolation. Beauty does not cancel difficulty, it simply exists beside it. After several minutes, someone moves first. The temperature is beginning to reach through the clothing. A few people return inside, others remain a little longer. Eventually you turn back as well. The station door opens. Warm air begins your face. Outer layers begin coming off. Conversation resumes almost immediately, but something of the moment follows everyone inward. Later, in your room, the station is quieter. Somewhere in the corridor, a door closes. The ventilation continues its steady movement. The building is doing what it has done every hour of the winter, holding a small human community together inside an environment much larger than itself. And by now you understand that the walls are only part of what makes that possible. The other part is less visible. It is the shared meal, the closed door respected, the radio check answered, the cup left warm, the invitation to step outside and look up. Winter is being survived collectively, one ordinary act at a time. By this point in the winter, the most difficult question is no longer whether the body can live without sunrise. It can. The more interesting question is what the body begins to treat as sunrise instead. For most of your life, morning arrived before you had any reason to think about it. Light entered through a window. The sky brightened. The eyes registered that change, and the brain adjusted thousands of small processes around it. Hormones shifted. Body temperature began to rise. Alertness increased. The timing of sleep from the previous night was quietly placed into a larger 24-hour pattern. None of this required a conscious decision. Here, consciousness has been pulled into the process. You wake because an alarm tells you to. The room becomes brighter because the lighting schedule says it should. You eat because breakfast has been assigned a place on the clock. You exercise because movement belongs to this part of the manufactured day. And after enough repetition, the body begins anticipating these events before they happen. This is one of the useful properties of circadian biology. The internal clock is not perfectly rigid. It is responsive. Light remains its most powerful environmental timing signal, but behavior can reinforce the pattern around it. A regular sleep period, consistent meals, physical activity, social contact, and carefully timed exposure to brighter and dimmer environments all help give the day a repeated shape. The result is not that polar night disappears from the body. It does not. Studies of people living through high-latitude winters have found changes in sleep, mood, alertness, and circadian timing, although those changes vary widely from person to person. Some people remain relatively stable. Others struggle more. A person who naturally prefers late evenings may respond differently from someone whose body tends toward earlier sleep and waking. Work schedules matter, light exposure matters, individual sensitivity matters. Even the station itself matters. A brightly illuminated, modern facility creates a different biological environment from an older building with dimmer indoor light. Two people can live through the same polar winter and experience it differently. This is important because the phrase adaptation can sound too complete, as though there is a point when the body finally understands the situation and the problem is solved. It is closer to negotiation. The station gives the body repeated cues. The body responds. Sometimes the agreement holds, or sometimes it slips. There may still be nights when sleep arrives later than expected. There may be mornings when artificial light feels less convincing than it did the day before. There may be an afternoon when concentration is poorer for no obvious reason, or a scheduled evening when the mind becomes unusually alert just as the rest of the station begins winding down. Living here means learning not to interpret every variation as failure. Sleep is variable everywhere. The difference in polar winter is that the environment makes you pay closer attention to the variation. You begin noticing things that ordinary daylight once concealed. How much brighter light in the morning changes the hours that follow. How a late screen session can make sleep feel farther away. How exercise at a consistent time can divide the day into recognizable sections. How even one badly timed nap can make the following night feel slightly displaced. The body becomes something you observe, almost the way you observe the weather, not anxiously, simply with more information than you used to have. There is a temperature to your alertness, a rhythm to hunger, a familiar moment when the eyes become heavier, a particular point in the manufactured evening when conversation feels less appealing and the privacy of your room begins to sound better. These patterns slowly become trustworthy, and this is where an interesting reversal takes place. At the beginning of winter, the clock felt artificial and the sky felt real. Weeks later, the clock has become the more useful source of information. The sky still tells the truth about astronomy. It tells you that this latitude is tilted away from the sun. It tells you that Earth continues along its orbit. But it can no longer tell you whether your body should be beginning a work shift or preparing for sleep. For that, you turn inward to the small world the station has built. Light becomes morning because it arrives every morning. Dinner becomes evening because it has happened at the same part of the cycle for weeks. A dim room begins to produce a familiar response. The sequence acquires meaning through repetition. There is something deeply old in this. Long before electric light, human communities organized time socially as well as astronomically. Meals, work, gatherings, bells, watches, fires, rituals, and shared obligations divided days into recognizable parts. Sunlight provided the largest framework. People supplied many of the smaller ones. At a polar station, that relationship becomes more visible because one of the largest natural cues has been temporarily removed. What remains is the human ability to construct rhythm together. You can see it most clearly around the edges of the day. In the morning, doors begin opening within a narrow span. Footsteps move toward the same common spaces. The smell of coffee appears. Voices remain low for a while. Computers come online. The building brightens. By itself, none of this is sunrise. Together, it begins to function like one. Hours later, the opposite pattern arrives. Work ends. Lighting becomes less intense. The corridor grows less active. People disappear into smaller rooms. The station seems to contract. Again, none of this is sunset. But after months of repetition, the body may begin responding before the lights have fully changed. Sleepiness can become attached to the sequence. This attachment is one reason consistency matters so much. It also explains why irregular work can be especially demanding. Scientific stations do not always have the luxury of perfect schedules. An instrument can fail during the planned sleep period. Weather can create a narrow window for fieldwork. A satellite pass may occur at an inconvenient hour. An emergency does not consult the lighting program when a researcher has to work through the station's artificial night. The disruption can feel larger than an ordinary late evening elsewhere. There is no natural dawn waiting outside to help restore the pattern. The crew has to rebuild it deliberately afterward. Sometimes that means protecting the following sleep period more carefully. Sometimes it means adjusting light exposure. Sometimes it simply means accepting that the next day will feel slightly less organized. The important thing is not perfection. It is recovery. A stable routine can absorb an occasional disruption because the larger pattern remains intact. The same is true emotionally. There may be days when the winter feels heavier. No amount of routine makes distance disappear. No lighting system removes homesickness. No shared meal guarantees that every person will feel sociable. The goal of station life is not to eliminate every difficult response. It is to prevent those responses from becoming directionless. There is always another meal, another scheduled morning, another conversation, another work period, another night when the lights dim. The structure gives difficult hours somewhere to end. And that may be one of the quieter reasons routine becomes comforting here. Predictability reduces the number of decisions a tired person has to make. You do not have to decide when morning begins. It has already been decided. You do not have to invent a new sleep strategy every night. The room, the schedule, and the habits around it have already been arranged. When the outside world offers very few temporal landmarks, repetition supplies them. After enough weeks, even the bedroom begins to feel different. At first, it was merely the place where you tried to sleep, despite the strange season. Now it has acquired associations. The lamp at its lower setting, the book on the shelf, the sound of clothing being put away, the familiar temperature, the door closed against the corridor. These details tell the nervous system something before sleep has arrived. Work is over. Nothing else is required right now. You lie down. Outside the window, the sun is still somewhere beneath the horizon. Inside, the room is no darker than it was 12 hours earlier. Yet the distinction between day and night has returned. Not to the sky, to you. And in the middle of a season defined by the absence of sunrise, the body has begun doing something quietly impressive. It has learned that morning can be recognized by more than light from the sun. The return of the sun begins long before anyone sees it. At first, there is no sunrise. There is only a difference in the horizon. For weeks, the station has been surrounded by a sky that changes very little during the hours people call day. Then, almost without announcement, a thin region near the horizon begins holding a little more color than it did before. Not bright enough to cast shadows. Not bright enough to illuminate the landscape in any ordinary sense, just enough to be noticed. The change is astronomical before it becomes emotional. Earth has continued along its orbit while the station lived through winter. The hemisphere that had been leaning away from the sun is slowly changing its orientation relative to it. From the station's latitude, the sun is still below the horizon, but each day its highest point comes a little closer. That difference can be measured. It can also be felt. During the deepest part of polar night, the sun may remain far enough below the horizon that even its indirect illumination contributes very little to the sky. As the season advances, the geometry changes. The sun rises higher beneath the horizon, and the upper atmosphere begins catching more of it. The first visible sign may appear as astronomical twilight. Later comes nautical twilight, then civil twilight. When the hidden sun is close enough to the horizon that the landscape begins to separate faintly from the sky. These names are technical, but living through them makes them surprisingly physical. One week, the horizon is simply black. Another week, it contains a thin blue-grey band. Later still, that band lasts longer. A ridge that had been invisible without a headlamp becomes faintly visible. The outline of a neighboring structure appears against the sky. Snow no longer exists only inside the beam of artificial light. The world begins returning by degrees. People notice. Not everyone mentions it the first time. Someone standing beside a window may simply remain there a little longer than usual. A researcher walking from one building to another may switch off a headlamp for a moment to see how much of the path can be made out without it. At breakfast, someone eventually says that the horizon looked brighter yesterday. Another person agrees. Then everyone begins watching. This is one of the rare times when a change measured in minutes can feel large. The increase in twilight from one day to the next may be modest, but after a long period of near sameness, the eye becomes sensitive to small differences. A little more blue, a little more definition, a slightly longer interval before the sky darkens again. The station calendar has always known this was coming. Tables can predict the sun's position precisely. The crew could calculate the expected return of direct sunlight long before the winter began. Yet, prediction does not remove anticipation. Knowing that something will happen is different from seeing the first evidence that it has started. The artificial day continues inside. Lights still brighten at the scheduled morning hour. Meals still arrive on time. Work continues. Nothing about the station's routines is abandoned because a trace of natural twilight has returned. If anything, the contrast makes those routines easier to understand. For months, the building has been carrying the full responsibility for telling the body when day begins. Now the environment is beginning to contribute again. Not much, just enough. A researcher who walks outside during the brightest part of the new twilight may find that the sky suddenly has direction. There is a brighter side. There is a darker side. For the first time in a long while, the location of the hidden sun can almost be inferred. This matters because natural light carries qualities indoor illumination cannot reproduce completely. Outdoor light varies across enormous ranges of intensity. Its spectrum changes with the sun's angle. It arrives from a sky rather than from fixtures positioned a few meters away, even when the sun itself remains hidden. Spending time in the growing twilight can provide the visual system with a stronger sense that the season is changing. The body receives that information quietly, so does the mind. A landscape that had become abstract begins acquiring detail again. Snowdrifts reveal curves, edges appear around buildings. The horizon returns. Distance becomes easier to judge. The station is no longer the only visible object in the world. This can make the surrounding space feel larger. During the deepest night, artificial light creates islands. A window glows. A headlamp creates a small moving circle. A vehicle throws a beam across the snow. Beyond those islands, the world disappears. Twilight reconnects them. The space between buildings becomes visible. The field beyond the station exists again as something more than darkness. Even the sky seems higher once the horizon is visible beneath it. And then there are colors. Polar winter does not return directly from black to blue daylight. The transition can contain long bands of gray, violet, pale orange, deep blue, and muted gold, depending on atmosphere, clouds, ice crystals, and the sun's position beneath the horizon. After months in which most outdoor color came from aurora, instrument lights, reflective clothing, or the illuminated windows of the station, these natural colors can seem unexpectedly rich. No one needs to exaggerate them. Their power comes from familiarity returning. Blue sky is one of the most common sights on Earth. Here, it can feel newly discovered. The change also begins affecting how people speak about time. During the deepest winter, tomorrow often meant another day like today. The external world offered very little visual evidence of progression. Now people begin referring to the coming weeks different, the next stage of twilight, the date when the sun should first touch the horizon. The first day it may remain visible for more than a few minutes. The season acquires direction. There is somewhere for time to go. That does not mean the winter suddenly becomes easy. Fatigue accumulated across months does not vanish because the horizon brightens. Sleep still depends on routine. Relationships still require patience. The cold may remain severe. Equipment still fails. Wind can still erase visibility. But the return of light introduces a new reference point. The season is no longer only something being endured. It is something visibly changing. This can be strangely reassuring. Human beings are good at living inside cycles when the cycle can be perceived. A sunrise, a tide, a season, a familiar sequence of stars. The difficulty of polar night is partly that one of the most obvious cycles disappears from immediate experience. When twilight begins growing again, the cycle becomes visible before it becomes complete. You can stand outside and see the orbit of Earth indirectly written across the horizon. Nothing in the station caused this. No generator produced it. No schedule maintained it. No technician calibrated it. The planet simply kept moving. That may be the most restful fact of the entire season. The crew has spent months constructing time carefully from human systems, and those systems mattered. They kept sleep organized, work coordinated, and daily life coherent. But beyond all of that effort, the larger clock never stopped. Earth continued around the sun at the same pace. The axis remained tilted. The geometry changed degree by degree. And now, at last, the consequences are beginning to reach the station as light. Later in the day, the horizon darkens again. Stars return. The station windows regain their familiar brightness against the snow. Someone closes a laboratory log. Someone begins dinner. Someone else steps into the corridor carrying laundry. The ordinary manufactured evening resumes. Yet something has changed. Everyone knows that tomorrow, the twilight may last a little longer, and the day after that, longer still. The sun remains below the horizon tonight. But it is no longer retreating. It is coming back. The first sunrise does not arrive like a surprise. Everyone knows the date. They have known it for months. It is written into astronomical tables, station calendars, weather briefings, personal notes, and conversations that became more frequent as twilight returned. Still, on the morning itself, people begin gathering early, not because they doubt the calculations, because there are some things a calculation can predict perfectly, without replacing the experience of seeing them. Outside, the horizon has already been brightening for some time. The long blue-grey interval that once seemed remarkable has become familiar. Each day it has stretched a little farther, carrying more color, more definition, and more of the feeling that the outside world is becoming available again. Today, something different is expected. The sun itself. The crew dresses for the cold, outer layers close over indoor clothing, gloves go on, hoods rise. Radios are carried mostly from habit, even though nobody intends to travel far. People step through the station entrance in small groups and spread out across the snow. There is no rush. The horizon is clear enough. A few clouds hang low in one direction, but the place where the sun is expected to appear remains open. For several minutes, nothing seems to happen. The sky is already brighter than it was a week ago. A pale orange band rests above the horizon. Higher up, the blue deepens toward the remaining stars. The colors shift so gradually that it is difficult to identify the moment one becomes another. Then the lowest part of the horizon begins to intensify. A thin line brightens. Someone notices first but says nothing. A few heads turn toward the same place. And then a small portion of the solar disk rises above the edge of the world. It is only light, the same star that has been present throughout the winter. Nothing has switched on. Nothing has returned from somewhere distant. The sun was always there, while Earth's tilted geometry kept it below this particular horizon. Yet the first direct beam changes the entire landscape. Snow that had been blue and grey suddenly carries gold along its upper surfaces. Edges become sharper. The side of the station facing the sun brightens. Long shadows extend across the ground, faces behind goggles turned toward the horizon. For a crew that has lived through months without direct sunlight, the effect can be unexpectedly physical. Eyes narrow, people blink, some simply stand still. The sun is low enough that its light travels through a long path in the atmosphere, where scattering removes more of the shorter blue wavelengths and leaves the horizon warmer in color. It may not provide much heat. At these temperatures, nobody mistakes it for spring. But warmth is not what anyone came outside to feel. The light itself is enough. A researcher lifts a gloved hand and watches sunlight fall across the fabric. Someone takes a photograph. Another person does not. There are moments worth recording and moments a person prefers to experience without. A device between the eye and the world. The sun remains close to the horizon. At very high latitude, its first appearance may be brief. The disk rises only slightly before following a shallow path and dropping away again. The entire event can be over quickly. But duration has little to do with importance. The first sunrise closes a loop that began with the final sunset months earlier. Between those 2 points, the crew has lived inside an altered version of time. They learned to trust electric light in the morning. They learned that lunch could happen beneath stars. They learned that sleep could be organized without sunset. They learned the sound of heating systems, the limits of cold weather equipment, the usefulness of a common table, and the value of a closed bedroom door. The sun's return does not erase any of that. It reveals how much has changed it. There is a generational thread running through this moment. Polar crews have waited for returning sunlight for as long as people have wintered at high latitudes. Different stations have developed different customs around the season, but midwinter and the return of daylight have long served as meaningful markers in communities cut off from the ordinary calendar of the world beyond them. The details change with place and era. The recognition does not. People living under a sky without sunrise notice when the cycle turns. Long before modern research stations existed, communities across the Arctic organized life around seasonal changes in light that were directly tied to travel, hunting, weather, food, and movement across land and sea. For them, the return of daylight was never merely decorative. It belonged to the practical structure of the year. Scientists standing here now inhabit a very different world. They have precise clocks, satellite communications, electric lighting, weather models, insulated buildings, instruments that can measure the sun's position far more accurately than human eyes could ever need. Yet, for a few minutes, they are participating in something much older than the station. They are watching seasonal light return. The modern equipment does not make that experience obsolete. It simply allows the crew to understand more precisely why it is happening. Earth's axis is still tilted, the planet is still moving around the sun, the latitude is still controlling the angle. Those facts are simple enough to teach in a classroom. Here, they have become architecture for an entire winter. The station exists partly because this geometry creates environments found nowhere else on Earth. The science exists partly because those environments affect atmosphere, ice, biology, magnetism, weather, and human physiology in distinctive ways. And the people standing on the snow have spent months living inside the consequences of one familiar astronomical fact. A tilted planet has seasons. At the poles, seasons become extreme. The sun dips again. Its upper edge remains visible for a little while, then disappears below the horizon. Nobody seems disappointed. This is not another loss. Everyone knows what happens next. Tomorrow, the sun will climb slightly higher. In the days ahead, the visible interval will lengthen. Eventually, daylight will begin competing seriously with the station's artificial schedule. Curtains that once kept corridor light out of sleeping quarters will become useful for another reason. The problem of too little sunlight will gradually move toward the opposite polar condition. Farther into the season, the sun may remain above the horizon for extremely long periods. At the highest latitudes, polar day will eventually replace polar night. The sky that once refused to provide morning will become reluctant to provide darkness. For now, though the balance is temporary and delicate, the sun has appeared. That is enough. People begin walking back toward the station. Boots compress the snow. Someone makes a joke about needing sunglasses again. Someone else looks back once more before entering. The door closes, outer layers come off. Gloves are placed where they can dry. The day's scientific work resumes. This may be one of the most striking things about the first sunrise. Afterward, there is still work. A sensor does not care that the crew has just experienced a seasonal milestone. Data still need checking. A maintenance task is still waiting. Weather observations continue. The routine that carried everyone through darkness remains useful even after the natural light begins returning. Breakfast still belongs at breakfast. Sleep still needs protection. The artificial day is not discarded the moment the real one reappears. Instead, the two begin slowly overlapping. For months, the station has been holding time together from the inside. Now the planet begins taking over again. A little more tomorrow, a little more the day after. The transition is gradual enough that no single morning has to bear all the meaning. The crew can simply notice there is light on the wall that was not there before. A window looks different. A corridor no longer seems completely separated from the world outside. The horizon has become part of the day again. And beneath all of this, the researchers continue moving through the same rooms, carrying forward habits formed during the long night. The winter taught them how to live without sunrise. The returning sun now begins teaching the station how to let it back in. By the time the sun has returned for more than a few minutes each day, the station no longer feels suspended outside the ordinary year. Light begins entering the rooms on its own. At first, it appears low and angled, sliding across a floor or catching the edge of a window frame. Later, it reaches farther into the building. Shadows move differently. The distinction between morning and evening no longer depends entirely on switches, schedules, and carefully managed lamps. The world outside has started keeping time again. That does not mean the station simply returns to what it was before winter. The people inside it have changed their relationship with time. Months earlier, daylight had seemed automatic, a background condition, something so reliable that its absence was difficult to imagine until the final sunset had already passed. Now the smallest change in natural light is noticed. A brighter horizon, the first direct beam on a wall, the moment when a headlamp is no longer needed for a familiar walk, the first morning when opening a curtain produces information about the hour. These are ordinary things almost everywhere else. Here, they have become measurements. The body notices too. Natural morning light begins joining the station's artificial cues. Sleep timing can become easier to anchor as outdoor illumination strengthens, though adjustment remains individual and gradual. The routines built during winter do not suddenly lose their value. They continue providing structure while the environment begins contributing again. This overlap may be the most stable part of the transition. The station does not abandon discipline simply because the sun has returned. Meals remain regular. Work continues on schedule. Sleep still deserves protection. The lighting system still matters, especially on cloudy days and during hours when the sun remains low. But the burden is no longer carried entirely indoors. The sky has begun helping. For the winter crew, this shift can feel larger than it looks. They have spent months building a day from human decisions. Wake now, eat now, work now, dim the lights now, rest now. Those decisions were repeated so consistently that they became almost invisible. And then one morning, sunlight enters the corridor without asking permission. The planet has resumed part of the work. Soon the practical challenges will begin changing. As daylight grows, some stations move toward very long days and eventually toward continuous summer light. Bedrooms that once faced months of darkness may later need strong curtains to create darkness artificially. The problem reverses. First, the station had to manufacture morning. Later, it may have to manufacture night. This is one of the clearest reminders that polar life is not defined by one condition. It is defined by extremes of rhythm. Darkness expands, then contracts. Light returns, then lingers. The same tilted earth produces both. The people who work here learn to live between them. Eventually, the winter season begins moving toward its end. Flights may become more regular again. Supply operations change. New personnel prepare to arrive. Some members of the winter crew begin thinking about leaving. This can feel strange. For months, the station was nearly the entire physical world. Its corridors became familiar down to minor sounds. The timing of doors opening, the pattern of footsteps near breakfast, the particular hum of machinery at night. The people inside became woven into every part of the day. Then suddenly, the larger world begins approaching again. There will be airports, traffic, stores, crowded rooms, sunlight appearing and disappearing according to a pattern so normal that most people barely notice it. There will be many more faces, many more choices, many more sounds, and there may be a brief period when ordinary life feels less ordinary than the station did. Some habits formed during winter will fade quickly. Others may remain. A greater respect for regular sleep, a sharper awareness of morning light, the instinct to check on someone who has been unusually quiet, an appreciation for shared meals, a memory of how much comfort can come from a warm room after working outside in severe cold. These are small things. They are also part of what the season leaves behind. The scientific records remain too. Weather measurements, atmospheric observations, instrument logs, samples, maintenance histories, data collected during hours when most of the world was asleep and the sun was nowhere above the local horizon. That information moves outward. It becomes part of longer records. It is compared with measurements from other years and other stations. Some of it may contribute to research questions that take decades to answer. The crew may never know which ordinary reading will later become important. That is the nature of continuous observation. Much of its value cannot be identified in the moment. You measure because the record needs another day, then another, then another. A winter passes, years accumulate, patterns begin to emerge. In this, the station connects several scales of time at once. There is the circadian day, held together by light and routine. There is the polar season, created by Earth's tilt. There is the year, completed as the planet continues around the sun. And there are the scientific records, extending across many years. Longer than any single crew remains in place. A person lives through one winter. The station remembers more. That may be why the final days do not feel like a conclusion in the ordinary sense. The work continues after one crew leaves. Another group arrives. Another winter eventually comes. The sun descends again. The horizon loses light. The station closes around its routines. Lamps brighten in the morning. Meals become anchors. Researchers step outside under stars to maintain instruments. People learn the same practical lessons in slightly different ways. They discover that darkness changes sleep. That structure can protect time. That isolation requires both community and privacy. That cold makes simple tasks slower. That a building can become a small climate of its own, and that the return of sunlight can make a familiar star feel newly important. None of this makes polar winter easy. It does something more useful. It makes the extreme understandable. The months without sunrise are not an empty interval. They are a physical consequence of planetary geometry, a biological challenge, an engineering problem, a scientific opportunity, and a social experiment, repeated each year by people willing to live inside it. Tonight, somewhere at high latitude, a station is still awake. Perhaps the sun is below the horizon there. Perhaps it has recently returned. Perhaps another crew is only beginning to notice the days shortening toward winter. Inside, a light glows over a table. An instrument sends back data. Someone closes a laboratory notebook. Someone prepares a room for sleep. Beyond the walls, Earth continues turning through the dark. And beneath the horizon, the sun keeps its place.